This lesson is on friction, and we're going to introduce some vocabulary and look at the values that go with it. So just as a general statement, friction is related to atomic level forces that cause the surfaces to be attracted to one another. And we'll talk about that in class a little bit. There are two types of friction. The first is static friction, and that's a force that prevents an object from sliding on a surface. So for instance, if I had an object and it's maybe sitting on a table and someone tries to push that object, so they apply a force to it, but it's not moving. Acceleration is 0, and in this case the velocity is 0. Okay, so this object is not moving. But if acceleration is 0, the net force must be 0, so there has to be a force that's counteracting this applied force. So that must be friction, and since it's not moving, it's static friction. Okay, so it's the force that prevents an object from sliding on a surface. Whereas kinetic friction is a force that is felt by an object that is moving. So if I have my surface and an object, and say I'm applying a force, and this object is moving, well then that means that it's moving and if there's a surface, so there's got to be some kind of frictional force that's counteracting that. So that is Fk. And remember that friction always opposes motion. Now for the most part in my free body diagrams, I'm always going to use Ff and not Fs or Fk, and I'm just going to use the appropriate friction in the problem solving. So if you see me using Ff, you just have to know whether it's static or kinetic depending on the situation. So since friction is this attraction between the two surfaces, it obviously depends on the two surfaces that are in contact. So the value that the friction takes on is dependent on these. And the ratio between this frictional force and the normal force of an object is the constant called the coefficient of friction, and we use the symbol mu to represent that. So mu is the frictional force over the normal force. So it's the ratio of the frictional force and the normal force. So the coefficient of static friction is the ratio of the frictional force applied just before an object will start to move. Because obviously we can apply different forces to an object before it will move. So we'd have to determine the coefficient of static friction with that maximum force. So just before the object starts to move, that's the frictional force we have to use. So mu s is Fs max over the normal force. And the coefficient of kinetic friction is the ratio of the friction on a moving object to the normal force. So mu k is the frictional force due to the moving object or on the moving object over the normal force. We're going to do an example problem. So here we have a 0.4 kilogram puck sits on some ice. A force of up to 0.4 newtons can be applied to the puck before it will slide across the ice. Find the coefficient of static friction. And we're going to use acceleration due to gravity of 10 meters per second squared. So let's list our givens and required. The mass. We have acceleration due to gravity. We have the applied force, the max applied force that's used. And we know that it's not moving in the scenario because it's just before it starts to move. So V and A are both 0. and we are looking for mu s. So we'll draw our free body diagram. It has to have a gravitational force on it, and it's sitting on a surface, so it has to have a normal force. And since we're not on an incline, these are going to be opposite and equal. And we know we're putting an applied force on it, so there must be something holding it back from moving, and that's the frictional force. And since there's no acceleration, we don't need to put an acceleration arrow, but I will put an arrow just to say we're going to use this as positive, just to be consistent. So we know that F net is 0, since acceleration is 0. And that F net is also applied force minus frictional force. So that means that applied force is equal to frictional force. And we also know that Fg is equal to Fn. And we're looking for mu s, which we know is the maximum frictional force over the normal force. And because of these things above, we also know that mu s is the applied force over the gravitational force. And we can rewrite the gravitational force as well. So we can do Fa over mass times acceleration due to gravity. So now we can plug in some numbers. So we get 0.4 newtons over 0.4 kilograms times 10 meters per second squared, which gives us an answer of 1 over 10, or 0.1. And just take a look at this here. Since we have kilograms times meters per second squared, the denominator here is in newtons, so our units divide out. So coefficient of friction is unitless, and this should happen every single time you use or calculate the coefficient of friction. It should be unitless. So this tells me that the coefficient of static friction between ice and the puck is 0.1. And there you have it.